Good morning, my dear friends. Welcome. Let's begin with exercise 7.7. Okay. So, this is not going to be a completely new exercise. This is a continuation of actually exercise 7.5. Okay, 7.5, because in 7.5 we have done some special integrals, if you remember. 7.5 we have done some special integrals, so it's going to be a continuation of that integral only, exercise 7.7. I'll note down the formulas for you. You can just note down the new formulas. We've already done 3, 3, 6. So now we're going to do the last 3. We're done. So if you're done, then we can maybe start with the exercise. That is question number 1. That's a direct question. That question, root over of 4 minus x square. So its integral we can just write as root over 4. We can write it as 2 square minus x square with respect to x. So the formula that is given to you. A square minus x square, the formula a square minus x square, so you can use x by 2 root over of a square minus x square plus a square by 2 sine inverse x by a plus c. So let's use this x by 2 root over of the value of a here is 2, isn't it? 2 square, so 2 square minus x square plus a square by 2 sine inverse x by a plus c. So that's going to be x by 2 root over of 4 minus x square plus 2 cancel twice of sine inverse x by 2 plus c. Question number 2. Root over of 1 minus 4x square. Root over 1 minus 4x square. So integral of root over of 1 minus 4x square with respect to x. So it is always better for you to divide by the coefficient of x. I would prefer to have only x square. Okay, I would not wish to have any coefficient with x square. So what I'll do is I will divide. I'll take 4 common, so that's going to be 1 by 4 minus x square with respect to x. Okay. Alright. Now of course I can apply the formula. So always make sure that your coefficient is free. No? The variable that you have is free of its coefficient. So that will be always better for us to compare the formulas and solve. So that would be integral of 1 by 4, 4, that will be 2, root over of 1 by 2 square minus x square with respect to x. So 2 of course, and then this integral, this special integral. What was the formula for this? Again, just like the last one, a square minus x square. So that will be 1 by 2, if you look at the formula, this one, x root over of a square minus x square plus a square by 2 sine inverse x by a plus c. So I'll just multiply by 2 also in the meantime. So that's going to be 2 by 2x root over 1 minus 4 by x square plus 2 into 1 by 4 by 2. Sine inverse 2 will go up, x plus c. So that's x 1 by 4 minus x square plus 2 to cancel, 1 by 4 sine inverse 2x plus c. Of course, if you want to further simplify this by taking the LCM, 1 minus 4x square by 4 plus 1 by 4 sine inverse 2x plus c. So 4 root over goes 2. All right. Okay. Next, question number 3. I'll write down the integral directly. That is integral of root over of x square plus 4x plus 6 with respect to x. So here, of course, completing the square formula just like the previous exercise only, 7.567, yeah. Just we have now special integrals, that's all. Just like the previous exercise. We had 6 of them, so this one another 3. So there's nothing, so let's just quickly do. I hope you have practiced, you have gone through the videos. If not, do go through the videos and then come prepared. X square plus 2 into 2x plus 2 square plus 6 minus 2 square, completing the square method. Two we can write as root 2 whole square. So now in this case we will be using the formula in this one, number B, root over of x square plus a square. Okay, quickly note it down. Done. Okay. So that will be, I'll write it here once again. Root 2 whole square. So no need for substitution, because as I've always told you before also that there is no coefficient with x, so you don't have to worry. Substituting also, you will not be getting any extra coefficient, so we'll use the formula directly only. So what was the formula? That is x by 2. The value of x here is x plus 2. Okay, root over of x plus 2 whole square plus a square plus a square by 2 log of x, log of x. Okay, I'll just write here plus root over of x square plus a square plus c. This value you don't really have to expand, okay, because see, use your wits also, sometimes common sense. This value x plus 2 whole square plus root 2 whole square, see this value, if you go back comes from this value only, no? So we'll be using this value only, okay, directly. If you wish to calculate, you can calculate, that's up to you. Done. Question number 4. Same way, let's complete the square. Let's not waste much time here, let's just do it. Done. So I'll write that once again. Root over of x plus 2 whole square minus root 3 whole square. Alright, we can apply the formula now. So here the formula will be root over of x square minus a square. So that's that first one. If you have written down the formula, number 1. Minus a square. I'll just write here a square by 2 log of x plus root over of x square minus a square plus c. This value again, we can use the value directly. What was that? X square plus 4x minus 1. X square plus 4x plus 1, not minus 1. Done. Next question, number 5. Negative value, maybe we can sort it out. That is like 1. It depends on different people. Okay, let me just do it like this. Minus as a common whole. So x square plus 4x minus 1. That will be easier. Because minus x square, that again negative. Now, so there what will happen is if you want to apply the formula directly, then the negative sign will come. Then substitution you'll have to adopt. So let's avoid that. Let's keep the coefficient free. I mean coefficient of the variable free. Okay, x plus 2 or whatever be that, x should not have. Let's try not to give x any coefficient like plus, minus, or any numbers and all. So here I'll try to complete the triangle, complete the square, sorry. This is minus 5, so minus 5 I can write it as root 5 whole square. So this now negative value I can remove, so that is this root over of minus minus plus, so this can be rewritten or rearranged as root 5 whole square minus x plus 2 whole square with respect to x. So then we'll be just applying the formula for a square minus x square. Done. So let's apply the formula for a square minus x square. Alright, then let's apply a square minus x square. I'll write down the formula once again. So I'll start from here. A square minus x square formula. X by 2. A square minus x square plus a square by 2 sine inverse x by a. This value again directly we can use from the question. 1 minus 4x minus x square. This is 5 by 2 sine inverse of x plus 2 by root over of 5 plus c. Done. All right, number 6. So this will be x square minus a square. So that will be x by 2 root over of x square minus a square minus a square by 2 log of x. X value is x plus 2 plus root over of x square minus a square plus c. And this value we can use directly from the question because there are no special substitutions or any other calculations being done. For those who have been regularly practicing integration, they will not find this exercise difficult because it's a similar repetition of, as I said, exercise 7.5 only. So definitely they are not going to find this exercise difficult at all. Done. Let's move on to quickly 7. So likewise, as I said, you have a minus x square. So what we will do first, get rid of this negative value for for x square for the time being. It's going to be minus 1. Minus plus, plus minus, plus minus. X square minus 2, completing the square, so 2x, I guess 3 by 2. So plus 3 by class 12 standard, so completing the square should not be a problem at all. Four plus 9, 13 by 4. Root over of 13 divided by 2 whole square. So this negative value can be taken care of now. That is root over of 13 by 2 whole square minus x minus 3 by 2 whole square. Done. Note it down. Finished. Okay, so let's continue that. So here we'll be using the formula for a square minus x square. You have a minus here, but no problem, because as I said, the x is free from any coefficient, so even if you substitute, there won't be any extra terms coming. Okay, so without substitution, directly you can use the values. What was the value? Root over of 13 by 2 minus. Okay, so a square minus x square formula, na? A square minus x square formula, so x by 2 root over of a square minus x square plus a square by 2 sine inverse x by a plus c. So I'll take the LCM. 2x minus 3 by 2 into 2. Root over of this value can be written directly again from the question, that is, we haven't added any new terms, so we can go back. It's the same equation. Root over of 1 plus 3x minus x square plus 13 by 8 sine inverse of 2x minus 3 by root over of 13 plus c. Okay. You can note it down. We'll go to now 8. Alright, so x square plus 2 into x into 3 by 2 plus 3 by 2 whole square minus 3 by 2 whole square respect to x, so that will be root over of x plus 3 by 2 whole square. This is a much simpler question again with respect to x. So yeah, that's all. It's a very simple question. So now just apply the formula. So x square minus a square, the first formula, that will be x by 2 root over of x square minus a square minus a square by 2 log of x plus root over of x square minus a square plus c. Done? Note it down. Done? Alright, let's move on. So let's just simplify this. 2x plus 3, no, by taking the LCM, 2x plus 3, this is not whole square, sorry, x by 2 only, no? 2x plus 3 divided by 2 into 2. Root over of this value we can use directly. What was that value? Okay, simple one, x square plus 3x minus 3 square 9, 3 square 9, 2 square 4, 4 into 2 log of x plus 3 by 2 plus simple x square plus 3x plus c. The best. Okay, so one last question before we wind up for the day. Number 9, integral of root over of 1 plus x square by 9. Simple questions, actually these questions are much simpler. So that will be just root over of 1 plus x by 3. It's already a 1 square, it's already given, ready-made for you. So what is the formula for a square plus x square, or you can just arrange also x square plus a square. No, that's up to you. So let's use the formula x by 2 okay. Now as mentioned better for us, sorry, actually better for us because we have a coefficient. This one we slightly ignored, na? So instead of this, let's try to remove the coefficient of x square by taking LCM. So root over of 1 by 9 can be 3. Yeah, this will be much easier. So 1 by 3 integral of 9 is 3 square plus x square. Yes, this will be much better. Okay, 3 square plus x square. So 1 by 3 a square plus x square, or x square plus a square, that's x by 2 root over of x square plus a square plus a square by 2 log of x plus root over of x square plus a square plus c. Multiply x by 6 root over of x square plus 9 by 2 log of x plus root over of x square plus 9. Sorry, I have to multiply 1 by 3 also plus c. So 3 3s are 9, so rewriting it once again, x by 6 root over of x square plus 9 plus 3 by 2 log of x plus root over of x square plus 9 plus c. Okay. Alright then, so we'll wind up here for the day. Some more important questions are there. So those important questions, I'll upload the video for you. Kindly do watch the videos so that we can move on swiftly and prepare ourselves for the exams. Okay, I need your support for that. So the remaining questions, the other important questions, I'll be uploading it. So kindly go through it. So next up, we will start with definite integrals. So kindly do follow it up. All right, then I'll see you next time. Bye bye. Take care, all of you, and stay safe.